How Stable Diffusion generates images. If you've ever used AI art tools like Midjourney or Dream Studio, you've probably heard of Stable Diffusion. But what is it really, and how does it take a string of words, a prompt like a futuristic city at sunset, and transform it into a vivid, high-resolution image? To understand how Stable Diffusion works, we need to explore how artificial intelligence can imagine. At its core, Stable Diffusion is a text-to-image generation model. So, that means it takes in a natural language description and produces an image that matches that description. But the magic isn't in just recognizing words. It's in how the model reshapes noise into coherent visuals. Let's break it down. The foundation, latent diffusion models. Stable diffusion belongs to a class of models called latent diffusion models, LDMs. Unlike older image generation methods that worked directly in pixel space, which is computationally expensive, Stable Diffusion operates in a latent space, a compressed, learned representation of images. So instead of working on a full 512x512 image with all its pixels, it works on a much smaller, encoded version. Think of it like the brain's internal representation, more abstract, but still rich with structure. This reduces the computational load significantly and allows high-resolution images to be generated quickly, even on consumer GPUs. Step 1. Learning to denoisify. The key idea behind diffusion models is this: you can teach a model to reverse noise. The process begins with a clean image. During training, that image is slowly corrupted by adding Gaussian noise over multiple steps. Eventually, it becomes nearly indistinguishable from random noise. The model learns how to reverse this process, step by step, transforming noisy images back into clean ones. It's like teaching the AI how to imagine an image from a cloudy, scrambled mess. This process is called denoising diffusion. Step 2. Conditioning on text. Now comes the interesting part. How does the model make sure that the image it creates actually matches the prompt? That's where conditioning comes in. Stable Diffusion uses a powerful language model, CLIP-E, originally from OpenAI, to map text prompts into the same latent space as images. The model then guides the denoising process using that text embedding. So as the noise gets removed, it's not just guessing any image, it's being steered by the language prompt. The image becomes more and more aligned with the meaning of the words. Want a photo of a cat flying a spaceship? The model gradually forms that image by denoising in a way that matches the internal representation of that phrase. Step 3. The architecture. Stable Diffusion uses a UNet architecture at the heart of its denoising model. This neural network takes in a noisy latent and predicts a slightly less noisy version at each step. It's called a UNet because of its shape, an encoder and decoder with skip connections in between, allowing the network to preserve detail at multiple scales. It also uses crowd attention mechanisms, similar to those used in transformers, to help it focus on different parts of the image and text during generation. Combined, this architecture allows Stable Diffusion to produce highly detailed, context-aware visuals. Step 4. The scheduler. A scheduler defines the number of denoising steps and how much noise is removed at each step. Popular configuration use anywhere from 25 to 1,000 steps. More steps mean more precision, but also more computation. Some apps use smart scheduling to speed up generation without losing too much quality. The process is iterative. At each step, the model refines the image, removing a little noise while being guided by the text. Eventually, what started as pure noise becomes an artwork. Abstract. Step 5. Decoding back to pixel space. Once the final latent image is generated, it's still not in the form we can down view. So the model uses a decoder, part of the autoencoder it was trained with, to transform the latent representation back into pixel space. That's when the image appears on your screen. From random noise through dozens of guided steps to a coherent, high-quality picture, all based on your words. So, why Stable Diffusion matters. Stable Diffusion was revolutionary not just for its results, but for its openness. Unlike DALL-E or Midjourney, it's open source. Developers, researchers, and artists can fine-tune it, train new models, or integrate it into their own applications. This openness has sparked a creative and technical boom. People have trained versions for anime, for medical imaging, for architecture, and more. The model is also efficient. You don't need a supercomputer. With the right settings, you can generate art on a mid-range GPU in seconds. Use cases and implications. The applications are vast. Visual storytelling, product prototyping, game development, education, accessibility for artists without drawing skills. But there are also ethical concerns, from deepfakes to copyright violation to the misuse of personal likeness. As with all AI tools, the power of Stable Diffusion lies in how we choose to use it. Conclusion: Stable Diffusion doesn't draw in the way humans do. It doesn't understand art like we do. But it learns patterns, visual, linguistic, conceptual, and uses those patterns to generate images that often surprise even their creators. It begins with noise. It listens to your words, and it imagines step by step until something beautiful appears. And that's how Stable Diffusion generates images. Fine-tuning and customization. One of the most powerful aspects of Stable Diffusion is that it's trainable on new styles and concepts through techniques like Dream Booth and LoRA, low-rank adaptation. Users can teach the model new visual concepts, like a specific person, a brand aesthetic, or a fictional world. Once trained, those concepts can be invoked in future generations with simple prompts. This gives creators incredible control. A film studio could fine-tune a model on its art style. A designer could train it to replicate their unique aesthetic. Even individuals are creating personalized art models based on their photos or sketches. With a little data and training time, Stable Diffusion becomes a highly personalized creative tool. Prompt engineering. Generating great results isn't just about the model. It's also about the input. This is where prompt engineering comes in. By carefully choosing descriptive terms, modifiers, and reference styles, users can influence the output dramatically. For example, a photo of a forest might yield something generic. A mystical twilight forest, cinematic lighting, ultra-detailed, Studio Ghibli style, we'll steer the model much more specifically. Prompt engineering has become an art in itself, a collaboration between human imagination and AI interpretation. Many users also combine prompts with negative prompts, words or tags that instruct the model what to avoid, like blurry, low quality, or extra limbs. The more precisely you communicate your intent, the more accurate and so stunning the output becomes. Advanced use, inpainting, and ControlNet, Stable Diffusion isn't limited to full image generation. It also supports inpainting, editing specific parts of an image based on a prompt while keeping the rest intact. This is useful for changing a subject's face while keeping the pose, editing text or logos in art, replacing objects in a scene while maintaining lighting and perspective. Another powerful extension is ControlNet, which allows the model to follow additional control signals like pose, edge maps, or depth maps. Want your subject to match a specific pose. Want the background to follow a sketch layout. ControlNet enables that. These tools make Stable Diffusion not just a generation model, but an editing and enhancement engine. The future of generative imaging. Stable Diffusion is just the beginning. The foundational technology behind it is evolving rapidly. We're already seeing advancements like multimodal models that combine text, image, and even audio understanding, higher resolution output, through multi-stage generation and upscaling, real-time applications, like AI-powered video generation and 3D model creation. Soon, we may be able to generate entire animated scenes from a single prompt, or create immersive virtual worlds guided by text descriptions alone. This convergence of creativity and computation opens up new frontiers in entertainment, education, design, and human expression. But it also raises new questions. What does authorship mean when AI contributes to the process? How do we protect artists while encouraging innovation? How do we keep this technology accessible, ethical, and responsible? These are the conversations that must accompany the breakthroughs. Because Stable Diffusion isn't just a tool, it's a glimpse into the future of imagination itself. And the more we understand how it works, how noise becomes vision, how code becomes art, the better prepared we'll be to shape that future with care, creativity, and conscience. So next time you enter a prompt and watch an image appear, remember, you're not just typing. You're collaborating with a machine that learned how to see. Through data, through diffusion, through thousands of hours of training. And in that quiet moment between noise and clarity, something entirely new is born. That's the magic of Stable Diffusion.